Hey guys, I'm just going to walk you through writing functions in Trinket for those of you who just were not able to follow the lecture. So I'm going to record this for my students. So I'm going to go ahead and use Python Turtle to make this tutorial. So I'm going to go ahead and click on New Trinket and just choose Python. We'll just call it function demo. Let's not put a space. That's a bad habit. Okay, so function demo, and to start us off, let's go ahead and we got to import. We're going to use Turtle, so let's go ahead and import the Turtle package. And just in case you're not familiar, anytime I write a hashtag and it turns green, that's a comment. So this is actually ignored by the computer, so nothing happens if you run this program. But I'm going to now actually do it. I'm going to just do import Turtle. That's the package. And then after that, I'm going to create a Turtle object. Okay. So how you do that is you pick a name. So I'll just say any name. So you can make any name you want. And I'll just use the package turtle. So the lowercase word turtle is the package. That's the folder with all the code in it. And then uppercase T. This is actually the constructor for the turtle object. So if you were to go inside of the turtle package, you would find a class turtle, and that just actually creates the turtle that will move on the screen. Still, nothing's going to happen if I run the program, but I just like to run it just to make sure there's no compiling errors. So let's go ahead and define a function. So the way you define a function is in Python is you write the word def. So we used JavaScript before where we wrote the word function, but here you just write def. This tells the computer you are defining a function. And then you pick a name. So let's pick a name like draw square. Okay. All right. So if I want to draw a square, basically, let me change this. I don't want to do this. Let's just do Sven. We're going to use Sven because that's a nice, easy name to write. So Sven will go forward some number, let's say 100 pixels. Okay, and then we'll have Sven turn right 90. Okay, and then we'll have Sven go forward 100, and then Sven dot right 90. And this is why, by the way, there are shortcuts in Python. You'll see this a lot. So for example, here I could just type FD 100 instead of writing the whole word forward, and I could do Sven.rt for right. So you start to use that. Now I probably should have used a loop for this since I'm repeating myself over and over again, of course, but that's not the purpose of this tutorial. So let's just go ahead and now again, we've just defined it. I just ran it to compile it to make sure there weren't any but this program right here is just a definition. This is not actually executed unless I call it. So let's go ahead and call our function draw square. And by the way, you'll notice that I'm no longer indented. As soon as I stop indenting in Python, that tells the computer that this code block is done. So you see how when I wrote this semicolon, it immediately put this little tab, and that's basically separating what's called a code block. Okay, the end of the code block occurs when I stop indenting. That's why this line doesn't go inside of the. This doesn't go inside when I collapse it. Okay, if I had indented it, let me just show you. If I had indented it so that it was vertically aligned, then it would be part of the code block, so it would disappear. So I really try to put that out there, and whenever I'm doing Python, because indentation means everything. So we try to make it right when we're doing Java or JavaScript, but you always want to make it right when you're doing Python. Otherwise, your computer program won't run right. Okay, so let's go ahead and call the function. You just do that by writing the name of the function. So we'll go ahead and draw a square, and we should see the drawing of a square. Okay, so notice that this program right here was pretty simple. What's cool about this is now I could draw lots of squares. So for example, I could go for I in range, let's do, I don't know, 100. Okay, I'll draw 100 squares. Now, if I run this, it's just going to keep running the same square over itself. So it's not really that cool because it hasn't really done anything. But if after I draw a square, I do something like turn, I don't know, let's just turn the Sven 4 degrees, then the second square will be 4 degrees to the right. So you get this nice little shape here. Okay, so that's kind of why it's fun to use functions. Instead of just typing all this code and then having to put all this code in here, I also could do a lot more if I had chosen to use parameters. Well, let's do that now. Let's go ahead and make one with parameters. And I believe in Python they like to use the word arguments. If you know why that is and what's the difference, really, I honestly don't know. I've been coding for quite a while, and I don't really know the difference between the words parameters and arguments. But if I had used those instead, it would look something like this. Let me go ahead and make, I don't know, let's just do a rectangle. And this time we'll take in 2 parameters. So rectangle has a width and a height. So I'll write those, I'll just use those words. So I'll say width, height. Now, you'll notice that these are not actually variables created. These are only passed in when you call the function. So if I want to make a rectangle with a specific width and height, I put those separated by a comma. So I have 2 parameters, so 2 variables. So it's basically allowing myself the flexibility to change how wide and how high it is based on when I write the word rect, and then I put parentheses. I can make it as big and as tall as I want. So let's do a loop here for I in range 2. We're going to have 2 of these. We're going to go Sven dot forward. We'll do the width. I'm really bad at typing. I don't know why. And then I'll have Sven turn right 90. Okay. And then I'm going to have Sven go forward the height. And then we'll have Sven turn right 90. Okay. Now, if I tried to draw this rectangle, so let's actually stop this code, and instead of doing that, let's actually just take this out. Okay. So I'll do rect, and I'll make 200 by 100. So now, if I stop this and rerun it, it's going to go 200 pixels and then 100 pixels down. And then what's cool is that I could draw another rect and do it like 50 by 75 or 76. It doesn't really matter because each time I run this function, so let's go ahead and run it again, it'll draw the 200 by 100, and then it will do 50 by 76. And so I basically allowed this to be a little bit more flexible. And by using arguments, I can reuse this code. So I could do some pretty cool stuff if I were to throw this in a loop. For example, I could do for I in range 50. Remember, I don't know if I've explained this before, but this is a variable that will count from 0 to 49. It doesn't include the 50. It goes up to 49, one before it. And that variable can be accessed. So for example, I can do rect, and I can do like 2 times I. So we'll start at 2 times I, and we'll do 5 times I. So basically what's going to happen is these rectangles are going to grow each time it goes through. So let's go ahead and watch it. So, well, actually the first time is 0, but then it goes there, and then it goes 2. So it's actually, each time it goes through the loop, let me actually print to the screen the value of I, so you can kind of see as it runs. So the value of I is 0, and then it's 1, and then it's 2, and then it's 3, and then it's 4. And so what's actually doing is it's using that value to calculate how far to go. And since this is going up in ones, it's going to constantly step very symmetrically. So it's kind of cool how you can do that. You can even also do some cool stuff like Sven.right. I don't know. I'm doing 50. We'll do 20 degrees or something. And then it'll still do the same thing, only they'll be a little bit offset. So it'll kind of be like a corkscrew or something like that. So you can get some pretty cool designs just by playing around with that. Okay. So anyways, I'll actually save this right here, and I'll link this into the description of this video, and hopefully you guys can understand a little bit more about functions by watching that. So hope you guys enjoyed it. Talk to you later.